Welcome to The Explainer. Today, we're going to dive into a massive shift that's happening inside factories all around the world. It's a journey from just fixing machines when they break to actually predicting their future. And let me tell you, it's a hidden revolution that's turning maintenance from a chore into a real science.
This quote right here, it gets to the absolute heart of what we're talking about. The old way of thinking was that maintenance was basically an emergency service, right? You swoop in after something's gone wrong. But the real mission, the modern mission, is to make sure that disaster never even happens to begin with.
And look, this isn't just some nice-sounding idea. We're talking about huge financial stakes. The data is absolutely clear. Making a repair in the middle of a crisis, after a machine has already failed, can cost up to 3 times more than doing that exact same repair proactively on a schedule. 3 times! That's massive.
Okay, so to really get how far we've come, you got to look back at where it all started. Let's dig into the oldest and, let's be honest, the most basic approach: run to failure.
I mean, the logic here couldn't be simpler, right? A machine runs, and it keeps running until it just stops. And then, and only then, do you go in and fix it. This has been a part of factory life since day one. It's pure 100% reaction. And you can totally see the appeal of this, can't you? Why spend money fixing something that seems to be working just fine? But the reality, which has been proven over and over again, is that this reactive strategy is, by far, the most expensive way you can possibly manage maintenance. So why is it so expensive? Well, think about it. When you have no idea what's going to fail or when, you have to be ready for literally anything. That means you're stocking a gigantic inventory of spare parts, you're paying huge amounts of overtime for emergency repairs, and of course, you're dealing with all that downtime, which just kills your production.
So yeah, clearly, just waiting around for things to explode wasn't a great long-term plan. This led to the first real evolution in how we think about maintenance, trying to get ahead of the problem by using a calendar. This is preventative maintenance.
So the big idea here was to stop reacting and start planning. This approach uses statistics, specifically something called mean time between failures, or MTBF. Basically, you figure out the average amount of time a particular machine runs before it fails, and then you schedule a repair just before you expect it to break down.
Now, this idea of an average lifespan is usually visualized with something called the bathtub curve. It all starts with phase 1, the break-in period. When a piece of equipment is brand new, the chance of it failing is actually pretty high because of any installation mistakes or small defects from the factory.
But once you get past those early hiccups, the machine settles into phase 2. It's normal, useful life. In this phase, the failure rate drops way down, and it stays low and stable for, hopefully, a very long time.
And then you hit phase 3. This is where the equipment just starts to get old and wear out, and the probability of failure doesn't just go up, it skyrockets. The whole goal of preventative maintenance is to schedule a repair right at the end of phase 2, just before you fall off that cliff.
So that sounds way smarter, doesn't it? It's a huge leap forward from just waiting for a disaster. But this system has a pretty major flaw, and it all comes down to this one question. What is the problem with relying on averages? And here's the issue in a nutshell. No machine is perfectly average. So by relying on statistics, you get trapped between 2 really expensive problems. On one hand, you might be doing unnecessary repairs on a machine that's in perfect health, just wasting time and money. Or, even worse, the machine fails before its scheduled checkup, and boom, you're right back in crisis mode again. And that brings us to the next, and honestly, the most exciting evolution in this story. This is the modern era of maintenance, where we stop guessing based on averages, and instead, we start listening directly to the machines themselves.
This is what we call predictive maintenance. And the key thing to understand here is that it's more of a philosophy, a whole new attitude. It's not about one single tool, it's a new way of thinking that uses real-time data on the actual condition of a machine to figure out what it needs.
So how do you listen to a machine? Well, you use a whole toolkit of amazing non-destructive technologies. Things like vibration analysis to feel for tiny imbalances, thermal imaging to spot components that are overheating, or even analyzing the oil to find microscopic metal bits that signal wear and tear. It's basically like a 24/7 fitness tracker, but for your most important industrial equipment.
And what's really cool is that the process itself is brilliantly simple. Step 1. You are constantly monitoring the machine's real-time condition. Step 2, because you're watching so closely, you can spot the absolute earliest, tiniest signs that a problem is starting to develop. And step 3, you can go in and make a small, planned, inexpensive repair long before it ever becomes a huge, catastrophic failure.
At the end of the day, it all comes down to this one idea. Early detection changes everything. Big mechanical failures almost never happen out of the blue. They build up over time. If you can catch them right at the beginning, you can minimize the damage, minimize the cost, and completely stay ahead of that failure curve.
So when you follow this whole journey from reacting to preventing to predicting, you arrive at the ultimate goal. And it's a complete redefinition of what the maintenance department is even for. It's about so much more than just fixing things.
The new mission, the real goal, is to achieve and sustain something called optimum availability. That means making sure that every single piece of equipment, every system in the plant, is online and running in perfect condition all the time.
I mean, you really can't overstate what a massive night and day difference this is. You go from being a reactive repair crew that's seen as a cost to being a proactive team that is actively driving the performance and the profitability of the entire plant.
And the results? They're just staggering. A plant that's still stuck in that old reactive mode might lose over 30% of its production time to maintenance delays. But a world-class organization that's using these predictive strategies, they can drive that number down to less than 1%.
And that right there is the big takeaway. This is why all of this matters so much. When you do it right, maintenance stops being a cost center on a spreadsheet. It transforms into one of the most powerful tools a company has to boost productivity, improve quality, and gain a serious competitive advantage. So we'll leave you with one final thought to chew on. In today's world, take a hard look at your organization's maintenance strategy. Is it still looking backward at what's already broken, or is it looking forward, using data and technology to predict the future?